Section 5.2, example 9, determine converges or diverges of a geometric series. Determine whether each of the following geometric series converges or diverges, and if it converges, find its sum. Ooh, okay, so to start off, let's do this. To start off, let us see what our value ends up being. So I don't see our very first term. I see an n plus 1 and minus 1. Let's convert it to where both of these are just n and see what we end up getting. Because we want to find the common ratio and find out what the first term is in order to find out what the whole sum is. All right, so from here, let's get it to where our exponent is n. So we have the sum as n goes from 1 to infinity. Up here we have an abundance of n, so I'm going to take one of them out. So -3 times -3 over n plus 1. And down here we have 1 less n. So what I'm going to do is multiply 4 to the top and bottom. So times 4 over 4. Actually, we could do that over in the first step. So let's multiply both top and bottom by 4. So in the numerator here, we end up with another 4, -3, and then we have times 4. Down here, we have 4 to the power n. Clean it up a little bit. N goes from 1 to infinity. -12. And we shouldn't have that n plus 1 anymore. -1 or -12 times, let's write it normally, -12 times a -3 over 4 to the power n. Now that we have it broken up like this, we have our common ratio. So based on the geometric series, if the absolute value of our common ratio is less than or equal to, actually just less than, not equal to, is less than 1, then the series converges. So we could find the infinite sum after that, but let's just see what we have. So from here, our first term, let's just make sure that we have everything correct. So the first term here is 1, 2, so that's a +9 over, actually just a +9. So when we let this equal 1, we have -12 times a -3 over 4 positive, and then we have 3, 9. Yeah, so we're good here. All right, so now that we have this, we could find our infinite sum. So the infinite sum, so sum of infinity, is equal to the first term, which the first term we just determined was 9, over our 1 minus our ratio. So 1 minus 1, or a -3 over 4. So we have 9 over, so 3 over 4, 4 over 4, that gives us a 7 over 4. And then multiply both top and bottom by 4, we get 36 over 7. And that is actually it. So equals a +36 over 7. And there we go. So there's that sum. So here, up here, we determined that it converges, and there we found our infinite sum. So it converges to 3 over 6. Let's move this down a little bit just so it doesn't interfere. All right, here, let's get our exponent to be equal to 1. So the sum as n goes from 1 to infinity. E to the 2n. I'm going to get the exponent by itself or the variable by itself. So the sum as n goes from 1 to infinity of e squared to the power n. Now, I don't know much about Euler, but I'm pretty sure that value is greater than 1. Let's just make sure. So e to the power 2. Oh, yeah, that's way larger than 1. So we have e squared is greater than 1. And because it's greater than 1, we don't converge to a value. We end up going off to infinity. So here we would have to say that the series diverges based on the geometric series. And there we go. Those are our 2 solutions. If you have any questions, please feel free to ask. Otherwise, bye.